Assalamu alaikum. In this video, I will show you the correction of the essay part of the final exam of last year. So the exercise 1, fill in the blanks. First question, an angle formed by one complete rotation and counterclockwise. So this angle, ضد عقارب الساعة, one complete rotation. So the measure of this angle is 2 pi in radian, since it's one complete rotation. True or false? We're writing cosine on terms of its cofunction. So what does the theory say? That the cofunction is sine, the cofunction of cosine, and it's 90 degrees minus this angle. We remove parenthesis, 90 degrees minus theta minus 30, and the final result is sine 60 degrees minus theta. It's different from proposal, so this is false. True or false again, let theta be an angle in standard position, terminal side lying in quadrant 2, in Q2. So we are in Q2. And we need tan theta. So in Q2, we all know that all STC, but in Q2, tan theta is negative. So this is false, since tan theta, in this case, equal minus tan alpha. So minus is missing. So it's also false. Next question, unit vector. A unit vector U in the same direction as the vector V. We need to compute the magnitude of V. Square root minus 3 square plus 4 square gives 5. So U will be 1 over 5 times V. So we divide all components of V by its magnitude, minus 3 over 5, 4 over 5, and we are done. Let U and V, two vectors, the dot product U dot V, this is easy. So it's 0 times 0 plus negative 3 times 3, and this gives negative 9. The angle in degrees between these two vectors. So we have two options. We can draw U0, negative 3. So U will be here, like this. V is 0, 3. V will be here. So here we see that the angle is 180 degrees. Or we use the definition. So the angle theta is cosine inverse of U dot V over magnitude U over magnitude V. It's cosine inverse of U dot V, already computed, 9, minus 9. The magnitude of U is 3. Magnitude V is 3. And this use calculator, it gives you 180 degrees. So if you want, it's cosine inverse of negative 1, which is 180 degrees. Last question in this exercise. A matrix of order 3 by 2. B is a matrix of order 4 by 3. What is the order of BA? So 4 by 3 3 by 2. So the order matches and the product will be of order 4 by 2. The order of the transpose, A is 3 by 2, so the transpose is 2 by 3. This is exercise 1. Exercise 2, out of 6 marks. Trigonometric identity. So we start with the left side, cosine x times sec minus x minus sine x over cosec x. So first things to do, we have a negative angle here. Sec is even. So sec of minus x equals sec of x. So we get cosine x times sec x minus sine x over cosec x. Then we express all terms in terms of sine and cosine. So sec is 1 over cosine minus sine x, and cosec is 1 over sine. So here we simplify 1, but here we multiply. So it's a division of a fraction. We multiply by the reciprocal, 1 minus sine square, which is equal to cosine square x, and we are done. Equation, exponential equation. So first step is that you have to write exponential to x as exponential x all square. It's property of exponentials. So to get an equation, a quadratic equation in exponential x. So here, you can use a change of variable. You call u equal exponential x, you solve in u, and then you come back to x, or you can also directly factor in exponential x plus 3 and minus 2 equals 0. I will continue here. So exponential x plus 3 times exponential x minus 2 equals 0. This means that exponential x plus 3 equals 0, or exponential x minus 2 equals 0. This gives exponential x equals minus 3, which is impossible because exponential is always positive. And this gives exponential x equal 2. And we write the equivalent logarithmic form, x is ln 2. So the solution set, we have one solution, which is ln of 2. Next question, trigonometric equation. So we have sine and cosine, two trigonometric function. We try to factor. We have sine x as a common factor times 1 minus 2 cosine x equals 0. Product equals 0 means sine x equals 0, or 1 minus 2 cosine x equals 0. This is known in 0 pi, open in pi, so we don't take pi. So here we have only x equals 0, okay? Because it's also equals 0 in pi, but it's not in this interval, so we don't take it. The second one, we isolate cosine. So cosine x equals half. We compute alpha, reference angle. Cosine inverse of half, which is pi over 3. And then all STC. Cosine is positive, We need 0 pi only, so we need only Q1 and Q2. And we want cosine half positive. So here, cosine half positive is in Q1 only. In Q1, theta is alpha. It's pi over 3. We don't take Q4 here because it's outside the interval. So the solution set here, we have two solutions, 0 and pi over 3. Last exercise, matrices. So 2A minus B transpose. 2A, we multiply all coefficient by 2. Plus 1 minus B transpose. So B is matrix 3 by 2. B transpose is a matrix 2 by 3, 2 rows, 3 columns. The first column will be the first row of B transpose, 2, 3, 0, 0, negative 1, 2. And we subtract 2 minus 2, 0, minus 2 minus 3, minus 5, 4 minus 0, 4, 4 minus 0, 4, 0 minus minus 1, 1, 2 minus 2, 0. AB, A is 2 by 3, B is 3 by 2, so the product exists. It's a matrix 2 by 2. Okay, so the first element, row 1, column 1. We take the first row of A and the first column of B and we multiply 1 times 2 plus negative 1 times 3 plus 2 times 0, which gives negative 1. And here, of course, you have to write the details. So row 1, column 2. Instead of the column 1, we take the column 2 and we make the same. So 1 times 0, negative 1 times negative 1, 2 times 2, this gives 5. Then row 2, column 1. Now we take the second row of A and the first column of B. 2 times 2 plus 0 times 3 plus 1 times 0, it's 4. And finally, row 2, column 2. Two times 0, 0. 0 times negative 1, 0. 1 times 2, 2. It's 2. And this is the matrix A, B. Now evaluate the determinant of C. What's C? So this is C. We want the determinant of C. Two, 1, 0, x squared minus 1, 0, 0, y1. We can use Sarus. We write 2x squared 0, 1 minus 1y. And we make the products, diagonals. So 2 times minus 1 times 1 plus 1 times 0 times 0, 0 plus 0 times 0 minus, we open parentheses. The other way, 1 times x squared times 1 plus 2 times 0 times y, 0 plus another 0, which gives, so the determinant of C is minus 2 minus x squared. We can add the question here, for which value of x C is singular, non-invertible. C is singular if the determinant is 0. So which means that -2 minus x squared is 0. So x squared is -2, impossible. So C is always invertible. Okay, even he didn't ask this question. And finally, last question. Find the values of x and y such that C is a symmetric matrix. A symmetric matrix. So a symmetric matrix means that CT must be equal to C. This is a symmetric matrix. So let's see. So this is the matrix C. The matrix CT will be, so this is the first column, will be the first row, 2x squared, 0. The second column will be the second row, and the third column is the third row. So these two matrices are equal if 2 is equal to x squared equals 1, 0 equals 0, this is satisfied. X squared equal 1 already written, -1 minus 1 satisfied. Y equals 0, 0 equals 0, okay. Y equals 0, okay. 1 equals 1, okay. So x is plus or minus 1. Don't forget plus or minus, or y is 0. This is the essay part of the final exam of last year.